This is TechCrunch.
Orbital mobility took center stage in the space industry last year, with venture capitalists funneling massive sums into startups developing tech for nimble satellite operations. So it's no surprise that one of the most recent deals is to Magdrive, a UK-based startup that says its electric propulsion system for satellites will deliver a higher thrust in a smaller form factor than anything else on the market. Spacecraft designers have to consider a number of trade-offs when purchasing or designing propulsion systems. Chemical-based systems have high thrust but low specific impulse or efficiency, while electric propulsion (EP) is very efficient but generates low thrust. Magdrive has developed an EP system that uses solid metal propellant to generate high-energy plasma, with the same high specific impulse as a chemical system, but a magnitude improvement in thrust and a magnitude reduction in mass, company co-founder and CEO Mark Stokes said. That means spacecraft operators can use electric propulsion for entirely new classes of missions without having to resort to heavier and more expensive chemical thrusters. It will allow the company to eat the electric propulsion market for breakfast and then come for chemical propulsion's lunch, Stokes said. A lot of the future of the space industry is going to be based around being able to rendezvous satellites, he predicted in a recent interview with TechCrunch. Typically, satellites are launched with just enough fuel to maintain their orbit over the lifespan of the mission, but more efficient propulsion could unlock entirely new capabilities, like sustained rendezvous and proximity operations for imaging or satellite servicing missions, avoidance maneuvers to reduce the risk of a collision on orbit, and stochastic movement or unpredictable orbits to make defense and intelligence satellites untraceable. Orbital mobility, sometimes referred to as dynamic space operations by Pentagon leaders, has become a huge area of interest for the Department of Defense. Magdrive was one of 6 startups selected for the Space Force's Hyperspace Challenge Accelerator last year. One of the biggest advantages with Magdrive's technology is scalability, Stokes says. Both of the startup's first products, systems dubbed Rogue and larger Warlock, can be deployed in a grid to combine thrust, or can literally just be built at larger form factors. The company is developing a super Magdrive that's the size of a dishwasher. Since Stokes and CTO Thomas Clayson founded the company in 2019, Magdrive has now swelled to a team of at least 20 and is preparing to demonstrate its first 2 full-scale Rogue thrusters on orbit this June. It raised a $1.8 million, €1.4 million seed round led by Founders Fund in 2020 and around $10 million in non-dilutive grants to get to where it is now, Stokes said. To go even further, manufacturing its first commercial products alongside continued R&D, hiring, and even opening a U.S. subsidiary with an office in Los Angeles, the company has closed a new $10.5 million funding round. The startup sees advanced propulsion as a kind of infrastructure that will enable the space industry's continued growth in the coming years. Rogue and Warlock are designed to be reusable, using metals like aluminum and copper, which can be found in space, which, on a longer time horizon, could be a differentiator. We can use the materials that are already in space to fuel the Magdrive as its propellant, whereas everybody else, chemical and electrical across the entire range of things, has to bring their fuel from Earth every single time, Stokes said. It's like building a new train every time you leave the station. You don't build railroads that way. This new funding round was led by Swiss fund Redalpine, with participation from Balerion, Founders Fund, Alumni Ventures, Outsized Ventures, 7% Ventures, and Entrepreneur First. After the first orbital demonstration this summer, Magdrive aims to fire a Warlock system in 2026 and a Super Magdrive in 2027. That's the key thing. All these new missions are all looking at being able to move as much as possible, not necessarily as fast as possible, not necessarily to last as long as possible. In those 5 years of operational life, how much can you move? Stokes said. What we're bringing is that magnitude improvement to just how much maneuvering you can do in those 5 years.